Hello and welcome to my Physics 2211 Lab 2. This lab's purpose is to practice calculating the force, acceleration, and coefficient of drag of an object while falling through the air. The system for this lab is a plushy octopus that I dropped from about 1 meter high, and the surroundings are the world and the floor. The goal of this lab is to try to have an object that when dropped would experience drag. We also want to find the force of drag and the drag coefficient that the octopus experienced using Newton's second law of motion and the force of drag formulas. In this lab, we will find that accounting for the force of drag will make our model more accurate when compared to a model which only accounts for the force of gravity. To get my data and initial conditions, I used the tracking software to track the octopus as it fell through the air. This gave me the height and velocity over time. I then imported the data that the tracker gave me into Excel to create a graph with trend lines, which gave me the data I needed to perform the calculations for the force that acted on the ball and the accelerations they caused. I used the net force and acceleration to calculate the acceleration due to drag. This is the value that I will use when updating the velocity vector in the code in combination with the acceleration due to gravity in the second model. I then used the average velocity to calculate the coefficient of drag, which came out to be 0.205. In the first model, I did not account for the force of drag. On the screen, you can see the code that I used and the following graphs and model. And then here we have the comparison between the actual data and the model's graphs. In the second model, I accounted for the force of drag. On the screen now, you can see the code and the following graphs and models. And now the comparison between this model and the actual data. The second model had a much smaller differential when compared to the actual data collected. Therefore, accounting for the drag is more accurate than ignoring it. This makes sense because of course there was drag as we are in the real world and the object experienced drag while moving through the air. The main sources of error come from the tracking software. It is not a perfect way to track the object as it falls through the air. This could have caused my initial data to be wrong, which would have caused my calculations and models to be inaccurate as well. However, I feel that the end result is the same, that the accounting for drag is more accurate than ignoring it. I used my initial calculations to calculate the terminal velocity, which comes to be negative 6.9 meters per second. In the case of the object being thrown downward initially, the terminal velocity would remain the same, as the terminal velocity is the point at which the force of drag equals the force of gravity, so the initial input would not affect this. The only factor that would change this would be if the coefficient of drag had changed. Thank you.